Okay, thank you very much for joining. Today we've come to our second tutorial for our computer system and networking unit. In previous tutorial, we looked into describing common unit and metrics, explained the role of different type of memories. Then we looked into explaining data representation. Also looked into explaining stored programming languages. And lastly, we looked into explaining the basic of logic operators. So in today's session, we're coming back to our hardware and software components, where we're going to look into the different types, what they do, and how does our computer benefit from them. We're also going to explain the use of different software applications to meet specific purposes. Then our third learning outcome, we're going to explain the principle of networks and network connectivity. So for this unit, we also have a merit and a distinction criterion, where with the merit one, we're going to assess the function of component within a chosen computer system. And our distinction activity, with our distinction learning outcome, we're going to recommend and justify a hardware and software solution to meet a specific purpose. So let's get into our presentation. So what do we mean by understanding hardware and software side of this? So we know that each computer is the combination of physical component and the logical component, which is our software. So in this section, we're now going to cover all the key components and interaction between hardware and software. So we do have a summary here from this table, which shows us what are going to, it gives us hardware components, for instance, and the description shows us what is the purpose. An example. So when it comes to hardware, we know this is a physical element of computer system. So examples of physical component, we have our CPU, our RAM storage device, input and output devices. Software, we're now looking into operating system or any sort of application which is built with the programming language. Again, operating system still part of the softwares, where this is operating system, which depending on which brand, will now have different type of operating system, and depends on which one you find yourself more comfortable working with. So application, we have system application, desktop application, we have any sort of type of application nowadays. So these are software designed to help users perform specific tasks. Firmware, this is a permanent software program into a hardware device, such as our BIOS drivers. These software allows our operating system to communicate with hardware devices. Then we also have middleware, where this software can now provide common service and capabilities for application outside of what's offered in our operating system. I did find a very nice video, which I would like to share with you. I hope the video was helpful and it showed us the different aspects of hardware components and software components. So let's look into them in detail. As we said earlier, we can look at our CPU as a starting point for all of our programs. So we know every command that is loaded into our machine and converted into human language, it's happening through our CPU. So the video showed us examples of type of CPU available in the market, such as Intel Core, i7, i9, and so on, or AMD Ryzen. So depending on what sort of computer capacity you're looking for, you now choose a CPU. Okay, so our random access memory, our RAM, is volatile, as we said, and is used to store data for an instruction for temporary access, quick access. So there are various types of RAM available in the market. Then when it comes to our RAM, our storage device, this is used, as you said, to store permanently, and we have hard disk drivers such as HDD or solid state drivers such as SSD. Then we also have input and output devices such as our keyboard, mouse, monitor, printers, and so on. Our motherboard is an electric circuit board, which our CPU sits at the top, and there are various types of motherboard out there. GPU, as we saw from the video, it gives us a really nice graphic and resolution. Type of operating system, which are pretty much popular to everyone. We know them such as Microsoft Windows, Apple Mac operating system, and Linux distribution. When it comes to application software, these programs are designed to help users for specific tasks. So we know Office, Microsoft Office, is a very well-known and used application software. Google Chrome, maybe Zoom, or any other application. Firmware, these are permanent software programs which are programmed into a read-only memory, and these are going to provide low-level control for devices' specific hardware. So, example for this is our BIOS or UEFI. Drivers. So we have plenty type of drivers. So these softwares enables our operating system to communicate with the hardware devices. So we now have drivers for speakers or graphic card or monitors and so on. And there are different brands that provide these drivers. Middleware, these softwares that will now connect different applications or services. So middlewares now have different systems to communicate and manage data. So what is the interaction that we see between a hardware component and a software component? So the interaction that we see, it is very fundamental for the operation of our computer system. So this will now allow our operating system to manage the hardware component and provide functionality for all our applications that are running. So example of interaction, we have boot process, which is simply when we starting off with powering off our computer. That's when our BIOS will now kick in order for us to have our hardware, which will now load into our operating system. Also, we have running applications where user can now open Word, for example, or for instance, our operating system can now allocate memory and our CPU can resource this application. Then we have device communication, where printer's driver will now translate the print commands from an application into a format that the printer can understand. Network communication, we have middleware like a web server, which handles requests from web browsers and interact with our databases. So now we're going to describe the component of different computer systems. So what are these components? We're now going to look into our table, which summarizes them in detail. So components that we'll find in our hardware are going to be motherboard, CPU, RAM, which is our random access memory, BIOS, CMOS, and our graphics processing unit. Input devices again would be keyboard, mouse, scanners, camera, microphone, and output devices which they return some value to us, such as monitors, printers, speakers, and communication devices such as network interface card, and hard disk card. Okay, so hardware component, again, we've looked into the video, which explained to us what it does. And our motherboard, we know that just simply act as a backbone, and it allows us to connect all our components, all our input and output devices. CPU, central process unit, execute the instruction or performs calculation. RAM temporarily stores data and instruction that have correctly been used by our CPU. BIOS, which allows us to initiate our hardware during the powering up of our computer. CMOS, which is complementary metal oxide semiconductor. This stores our BIOS settings and the system clock. GPU, again, we're looking into our graphic and resolution of our images and video. Expansion slots allows us to add additional cards and enhance our system capability. TPM, Trusted Platform Model, is now going to provide hardware-based security functions. Our input devices, we've already looked into keyboard, mouses, scanners, camera, microphone. Output devices, monitors, printers, speakers, and communication devices, which such as network interface card, will now allows us to connect to the internet. So when it comes to backup storage, we all know that our computer will either come as an HDD or SSD type of storage, depending on which computer we choose to purchase. USB flash drivers are still available in the market. Routable optical drivers, network attached storage, and cloud storage, which is where technology is moving into nowadays. So now I'm going to explain the use of different software applications to meet a specific purpose. So we've looked into hardware component. Now we're going to understand software and application and where do we find them. So we all know what our operating system does. Unit software, such as system management tools. This will now help us to analyze, configure, and optimize computers. And the application allows us to do our day-to-day tasks and activities. The operating system are always provided by big brands such as like Microsoft, Apple, and other companies. So we know that operating system are now the backbone of our computer, which allows us to manage both software and hardware. So nowadays, the latest version of Windows is the 11, which can be installed in any computer depending on if they have the capability to support this heavy update. Mac OS, which is the operating system from Apple Macintosh, and pretty much it runs only on Apple devices, while Windows runs on different type of companies, providers. Linux, Ubuntu. So this works a bit differently from Mac and Windows. This operating system is an open source and is popular in server, desktop, and embedded systems. So people that have the ability to work with Linux operating system do find themselves with the ability to do more stuff compared to people that just have Windows and Mac knowledge. With Unity software again, we will explain that these are tools that are designed to optimize and maintain computer systems. So example for them are antivirus softwares, disk cleanup tools, and backup softwares. So the apps that are available in the market, we all know these are Office, which is very popular and is common when it comes to IT professionals, where we now required to work with Outlook, Excel, create presentation with PowerPoint and so on. Also Adobe, depending on which sector you work, you might need to purchase some of these Adobe licenses, which allows you to work with graphic design softwares or video making softwares. Then other more common and accessible software could be Slack or Zoom, which we are currently using. So now we're going to explain the principles of networks and network connectivity. So when it comes to networking, it is very essential for designing, implementing, and managing effective communication systems. And here we have example of type of network connectivity. So we have wired and wireless, and also we have principle of networks, where we're going to look into simple topology, types of network, OC and TCP/IP model. Look into the 7 layers and what they do. data protocols, routing protocols, network performance factors, error control approach, virtual networking, and binding network service. So we know that nowadays everything is moving to the cloud, everything is wireless. So, but back until the early 2000s, we didn't have much of this wireless connectivity. So everything was wired. And back in the days, we used to have different type of cables and type of connectivity. So for instance, we have category 6, which is the standardized twisted pair cable for our Ethernet connectivity. After that, we have optical. So this will now include fiber optic and so on. Then we have Ethernet over power line, EOP, which is utilized for existing electrical wiring to transmit network data. Wireless connectivity, which we find everywhere nowadays. An example for them are Bluetooth, which allows us to share information within a short range of distance. Wi-Fi, which could be provided for a local area or could be spread across different buildings. And we have cellular connectivity, which this is available on our mobile devices and allows us to access the internet. So when it comes to simple topology, we need to look into how network connectivity works. So we have different types of topology, such as star, ring, and mesh. So with the star topology, we know that all nodes are now connected to a central hub, which this hub will now redistribute connectivity. While with the ring one, each node is connected to 2 or other nodes. And with the mesh topology, every node is now connected to every other node. So again, circling back to what we explained about Wi-Fi and how this can be found. So it's not just Wi-Fi, but when it comes to network, there are different types, such as personal area network, local area network, metropolitan area network, and wide area network. So depending on the nature and the need that we have for internet, we're now going to choose which type of network is more suitable for our case. Another important aspect of type of networking is to understand the OC model and the TCP and IP model. So with the OC model, this, as the definition says, this is a conceptual framework with 7 layers. So we have starting from our physical layer to our data link, network, transport, session and presentation and application layer, where once this is standardized, the function of telecommunication or computing system. So the IP model, which is a 4-layer framework, this will now include the link, internet, transport, and application. And this is used for internet communication. While data and protocols, these are now going to be a set of rules which are going to define how we're going to transmit and receive data. So protocol is just simply an architecture, and we're very much familiar with HTTP protocol, which is our hypertext transfer protocol. And this is used for transmitting files data into our web pages. FTP allows us to load allows us to transfer in files. So from our desktop, we need to load files into the web page. We now use the file transfer protocol. Transmission control protocol. This, on the other side, is going to ensure that we have reliable data transmission. And internet protocol, which is simply our IP address, is simply an ID. Let's look at this into an ID, an address for routing packages. Routing protocols again. We have different types for them. We have open shortest path first, border gateway protocol, and routing information protocol. So by looking at them with open shortest path first, we now have a link that states routing protocol used within an autonomous system. Border gateway protocol, this is a path vector protocol used to route data between different autonomous systems. And routing information protocol, this is a distance vector routing protocol used in small to medium-sized networks. When it comes to monitoring network performance, we're now going to look into bandwidth, which shows us the frequencies of data transmission, latency. So this is going to show us the time that it takes for our data to travel from the original point to the ending point. Packet loss. This, with the loss of data path during transmission, this is going to affect network performance. Also, we have error control approach, which allows us to look into simple error detection method, where the data is now sold and the total set from data. Also, we have CRC and ARQ. Virtual networking, where we now have a virtual local area network. It now allows us to create the creation of logical separated network with the same physical network. VPN, again, these are virtual private networks that allows us to encrypt our IP address and gives us a private network across the public one. Binding network service, such as socket and ports. These are simply endpoints for sending and receiving data across the network. Ports give us a logical endpoint for network communication. Now let's go to assess the function of computer within chosen computer system. So when it comes to assessment of function of computer within a chosen computer system, we can now look into analyzing our operating system. So for instance, I'm now going to choose a computer system for assessing the Cyberpoint gaming desktop bundle. So what we're going to need as a minimum requirement, we're going to need a processor of AMD Ryzen 5, at least 16 gigabytes of RAM, and 1 terabyte of storage. And our graphical card has to be provided by NVIDIA. So we can see that each component within the system will now play a very important role in ensuring optimal performance, particularly for when it comes to gaming and high-performing tasks. So here we have a detailed assessment of each of the components that we just looked into. We spoke about processor. Razor 5 is a high-quality one, which could be compared to like a Intel Core i5 or i7 due to their functionality. Memory with the 16GB RAM will have higher speed, and we can now store more data in a quick amount of time. Then we have 1 terabyte storage, which allows us to install as much applications as we want because we do have enough space. And also with the excellent graphic card, we now have a better resolution of our image. So activity 2D1, we're now going to recommend and justify hardware and software solution to meet a specific purpose. So this unit, this learning outcome will be very handy when it comes to writing our assignment, because now as an expert, we now have the ability to advise on what users should purchase when it comes to buying a gaming PC. So here's from our recommendation. We can now recommend as a CPU processor, we can recommend the AMD Ryzen 5. Memory, again, we recommend at least 16GB. RAM storage should meet the minimum requirement of 1 terabyte, and NVIDIA GeForce RTX 3060 Ti is an excellent graphic card. Cooling system, again, we have an example for a good one. Power supply unit, input devices and output devices as well. When it comes to recommending a software solution, so we've now moved to Windows 11. So Windows 11 will be more suitable for gaming, for gamer launcher. For example, we now can now advise on Epic Games launcher. Antivirus software, there are different types of companies that provide them. And here we have Beat Defender Total Security. Driver software, again, we now circling back to NVIDIA. And gaming units can now purchase MSI Afterburner. So when it comes at the end, we'll now be asked to justify our solution. So we can now compare those that we found with other brand or other models, and now we can now explain why we chose this and why do we think the performance of this component are way off better than the other ones. So this was everything for today's session. Any question?
Thanks, Victor. No, that was all very clear. I have previous experience, my dad was a bit of a computer nerd growing up, so I have sort of like first-hand experience like building my own like desktop PC, so a lot of it was quite familiar. But yeah, no, it was all really interesting. Thank you.
Okay, that's great. And I just wanted to remind you that we have no session tomorrow. We have a session on Thursday.
Sorry?
I just wanted to remind you that we don't have a session tomorrow. I'm not available.
Oh, do we not? I wasn't aware of that, but Thursday's fine. Yeah, that's not a problem.
Yeah. So we have a double session on Thursday.
Double session Thursday. Yeah, that's not a problem at all.
Okay, thank you very much.
All right, I'll catch you Thursday then, Victor.
Okay, that's great. Have a good rest of the day.
You too. Bye bye.
Bye bye.